Allison designs fancy boxes to fill with chocolates. Can you guys see that okay? Okay. These boxes are in the shape of a right square pyramid whose 8y represents the length of one side of the base, and 5y represents the height of the triangular face of the pyramid. Okay, so a large size box must be designed to have a volume of 1,000 cubic centimeters. So we're going to create an equation that can be used to calculate the length of the base and the height of triangular face of the box. All right, so what do we know? And we also know it has a volume of 1,000. Would you agree with that? Okay, so what is the height, or I mean the equation for a volume for a prism? Okay, that's for a rectangular prism. I agree with that. No, that's triangle. Or I could just say, hey, look, I have this handy dandy reference sheet. And what kind of shape do I have?
A square.
It's a pyramid, right? So I look and say, hey, look, there's my volume formula for a pyramid. I don't even have to think. So 1,000 is equal to 1/3 capital B times H. Okay? What's the capital B stand for? No, a small b stands for your baseline, but a capital B is the area of your base. Okay? And H is your height, right? Okay, so if I fold this up, I'm going to have a pyramid. This is 8y. And then this part here is 5y, right? Okay, but my height is from the point going down. Okay, so how do I find what my height is going to be? Well, if I do have, does everybody see where I have this little right triangle right here?
What did you get? 1,000.
The problem said it volume has 1,000.
Oh, okay. I was reading part of that.
Okay, so if I have this little triangle here, the slant height's 8y. I'm looking for the height of the triangle up to the point, and then from here to here, because it's halfway, that's going to be 4y. Agree with that? Okay, so what can I use to find H? Pythagorean theorem. So 5y squared is equal to 4y squared plus h squared, right? Okay, so that means that I'm going to have 25y squared is equal to 16y squared plus 8 squared. And so when I subtract, because that's my height, that's what I'm looking for. Okay, that gives me 9y squared. Oops, sorry. How do you find undo the square? With my square root, and so my height is going to be 3y. Do we agree with that? Okay? All right, so let's plug and chug what we know. Let's get my picture here. All right, so I have 1,000 times 1/3. Base area is going to be 8y times 8y. Everybody with me on that? And then my height is 3y. Good? All right, so what's 1/3 of 3? That's 1, so that just cancels. 8 times 8 is 64, and I have 1, 2, 3 y's. Good so far? Okay, so what's the first question asking me for? Write an equation. Use to calculate the base and height. There you go. There's my equation. Okay, good. Are you with me on that? Yeah, well, that's why we're recording right now. Okay. All right, now, there's my equation. Equals 64y cubed. So, the second part is I'm looking for the base and the height of the face. So that means I need to know what y is, right? How am I going to solve for y? Let's start with 1,000 divided by 64. So 15.625 equals y cubed. How do you find the cube root down the calculator? You remember this one? Didn't we talk about this yesterday? Yep. Yep, there you go. Hit your math button. So I have the math, and I'm going to go down to, hey, I want the cube roots of 15.625. And so y is going to be 2.5. But the question's asking for my base. And since the base is 8y, that means I have 8 times 2.5. Whoops, it'll help if I did it where you could see it. So times 8. So my base is 20. And then my height was 5y. So 5 times 2.5. And my height is 12.5. Good? That one just looks kind of complicated, but if you use your reference sheet, look at the key and go, what do I have here? It's not that ugly. Okay? We good on that one? Yes. All right. Kyle performs a transformation on a triangle. The resulting triangle is similar without even going on further. What do you know about similar triangles and transformations? Which one causes it? No, which transformation makes similar triangles? Dilation. Because what do the other ones do? They just move it. They're rigid motion. So, the resulting triangle is similar, but not congruent. What transformation did he perform? Dilation. Easy peasy one. Good. Okay. Talking about dilations. All right, we have vertices at 1, 1, 2, 5, 3, and 0, -3. It's dilated by a scale factor of 1/2 to create that triangle. And so what's the length of BC of the dilated triangle? All right, you with me on that? So we have to do two things. We gotta dilate it, and if it's scale factor of 1/2, is it gonna be bigger or smaller? Perfect. And then we gotta find the distance of it. So I am going to plot my point. Well, first of all, how do you, if I have A at 1, 1, how do I find the points for A prime? Why is it 0.5? You're correct, but why is it 0.5? Because you multiply both of the points. So I would have 1 times 1/2, and so I would have 1/2, 1/2. Oh, but I don't even care about A. I just need B and C, right?
Yep.
All right, so B is going to be 2.5 times 1/2 and 3 times 1/2. So 2.5 times 0.5 gives me 1 1/4. These are yucky points. And this is going to be 1.5. Okay. Everybody with me so far? Huh?
Where'd you get the 1/2 on the 2.5?
Because that's our scale factor.
Oh, okay.
Okay? All right. C is 0, -3. So we're going to have 0 times 1/2 is still 0. And -3 times 1/2 is going to be -1.5. Okay? So, 2 ways you can go about doing this. If I plotted B prime, it would be at 1.25, 1.5. So I can do it a couple of ways. Since I got these little decimal things, I'm going to make my scale 0.25. All right? So then I go 1, 2, 3, 4, 5. So this is 1.25. And then I got to go up 1, 2, 3. There's 1. Ooh, I got one more. And this is going to be 1.5. So there's my B prime. Is everybody with me on that? Okay, C is going to be 0 and -1.5. So 1/4, 50, 75, 1, 1.5 was here. Oh, my bad, thank you. Okay, now the reason I did it like that is because I can then make my Pythagorean theorem and go, how many do I have? Well, I've got 1/4, 1/2, 3/4, 1, 1/4, 1/2, 3/4, 2, 1/4, 1/2, 3/4, 3. So this is a distance of 3, right? 1/4, 1/2, 3/4, 1. This is then a distance of 1.25. And then I can do my Pythagorean theorem. So 3 squared plus 1.25 squared is going to give me my distance squared. Okay, so 1.25, there's my square button, there, plus 3 squared. Oh, 1.25, let's do it this way, squared plus 3 squared. And then when I take my square root of 10.5625, my distance is 3.25. Okay? Now, you can do it that way. You can use your distance formula. Anybody remember what your distance formula is? Your distance is the square root of x1 minus x2 squared plus y1 minus y2 squared. Okay? That one, since you had your points, you could have just plugged and chugged. Both ways are going to get you the answer, whatever's easier for you.
For the question, you're trying to B and C, though, right?
All it was asking for is what's the length of BC. Either way. Okay? Either way will totally work. Good? Better? Alrighty. 21. We have a proof. Okay? We're not even getting to the bottom part of this proof. We're only looking at the first 4 statements. So, let's look at what we have going on here. The statement is that there's 2 triangles similar. So, off the top of your head, what were the 3 ways you can prove 2 triangles are similar? Side angle side. Side, side, side. And that's congruent.
I say
And nope, that's the parts.
side, 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 angle, sides, angle, angle, angle.
Angle, angle. Yeah, we did. Yeah. Anyway, so bottom line, they give you a reason bank though, okay? So if I know that I'm looking for 2 triangles similar, I know it's got to be one of these 3. So I got to look above. What did I just prove above? There. What does this prove? 2 angles are congruent, right? What did this one prove? 2 angles are congruent. So what did I just prove? Which theorem can I use? AA, angle, angle. All right, does that make sense? All right, then when I go to the next one, I have no idea what they're kind of looking for. So I'm just going to come down here and look through my stuff and go, okay, well, it's none of those. Are we doing, is there anything about our corresponding sides of similar angles congruent? No, that's why they're similar. So that's not even true. Okay? If 2 parallel lines are cut by a transversal, then alternate and interior, yeah, that's true. But what do we have going on here? Do we have alternate interior angles? No. So 2 parallel lines are cut by a transversal, the exterior, we don't care. Corresponding sides of similar triangles are proportional. Is that what didn't we learn a theorem and it looked just like that about that? All right, so there's my reasoning. My corresponding sides, a similar triangle. So now when I look up here, it's not those, it's not about angles, so it's got to be these. Which one are corresponding sides? Well, PR is to PS, that's one. All to a part, so it has to be that one. Okay, does that make sense? So on some of these, you don't get bogged down by, don't get bogged down by like, oh my God, I don't know how to prove. Just look at what they're asking for and think about what did we learn about a picture that looked like this. Does that make sense? All right, good? All right. Map of the town, home and workplace. What's the shortest distance? First question, what's the shortest distance between 2 points? Think in terms of, if I have a point here and I have a point here, what's the shortest distance between them? The diagonal, right? It's not going to be shorter to go that way, right? Okay, oops, I keep getting down, sorry. All right, so between workplace and home, walking on only the dotted lines, what do you think is going to be the shortest way? The diagonal, right? Okay, so let's count. 1 block is for each square. So I go 1, 2, this part is 3 blocks right there, right? Okay, now to get this part right here, what am I going to do? I'm going to do Pythagorean theorem. So 2, and I have 1, 2, 3. So 2 squared plus 3 squared is 13. So there's the square root of 13. Good so far? All right, and then do we want to walk up or over? It's not really going to matter, is it? So there's 1 block. There's 1 block. And now for this, let's do Pythagorean again. So 1, 2, 3. 1, 2, 3, 4, 5, 6. So 3 squared plus 6 squared is 45. And now I can just add them all up, right? Say what? No, it says she walks only on the sidewalks indicated by the dotted lines. Okay, so square root, whoops, what? Square root of 45 from here to here, plus 1, 2 for around the square, plus the square root of 13 plus 3, and I get 7.1414. Okay, now let's look at, that's obviously more than 4 or 7. That's going to be more than 7. We're not going to go up and around, so that would be the shortest route. Would you agree? Plus 2 for here, and then plus 3 for down there. Okay, good? All right. 23. Equation is shown where x is greater than 0 but less than 90, and so is y. Cosine of x is equal to the sine of y. Do you agree with that? Okay. So create an expression for x in terms of y. So this is not, what do you know, when you hear cosine, sine, whatever, what's the first thing you think of? What kind of function are we doing? Yep, right triangle, absolutely. So that means this is 90, right? That means x and y have to equal 90. Do you agree with that? So how can I write an expression for x in terms of y? Subtract y, solve for x. Does that make sense? Yeah? So it's just x equals 90 minus y. Okay. All right, probability. Two events are independent. Probability A equals 0.3. The probability of A and B equals 0.24. What's probability of B? Do you remember the rule for testing for independence? Multiplying, that's half the way. Okay, so it was, if you have the probability of A times the probability of B, it has to equal the probability of A and B. Okay, that was just one of the rules we got. So let's plug and chug what we know. If 0.3 is A, and I'm looking for the probability of B, and that's A and B is equal to 0.24, I can just divide 0.24 divided by 0.3, and the probability of B is equal then to 0.80. Hi there, how are you? I'm wonderful. She's already up and packing up. Yep. Uh-huh. Bye. All right, 25, another probability one. Okay. We got 200 people attending a party. Probability of selecting a female is 0.6. Probability of selecting a child given the person is female is 0.25. Probability of selecting a male given the person is a child is 0.4. Complete the two-way. All right, so I got to get some right percentages in here. So start with the first one. Probability of selecting a female is 0.60. So that means I need the number of females over the total. But I already have those. That's not going to really help me with anything, does it? So that's just information they threw out at you. All right, let's do the next one. Probability of selecting a child given the person is female is equal to 0.25. Okay? Now, remember when we had the givens, that meant that we had the number of children on top over the total given. Do you agree with that? Does that ring bells? Okay, so how many children do we have? That's what we're looking for. Okay? Yeah, but we don't need the total because it's the child given the female. So we're looking for the female child right here. Okay? But my total given is 120, and that's going to be equal to 0.25. Is everybody with me on how I set that up? Okay, so if I multiply both sides by 120, those cancel, and x is equal to 120 times 0.25, which gives me 30. And now, how many male children do I have?
20.
And how many male adults do I have?
60.
And how many female adults do I have? So as long as you find that one with your probability, then you can back into all the other ones. Good? That one looks scarier than it really is. All right. 26. Picking fruit from a basket contains many different kinds of fruit. Whoops. Which set of events is independent? If it's independent, what does that mean? It doesn't depend on anything else. And there's a certain word we used. If I have cards and I pick a card, and then what'd you just say? Without replacement. Without replacement means you're independent. Okay? So, event 1, he picks a kiwi and eats it. Event 2, he picks an apple and he eats it. Is that the probability of the second event going to change because he ate the first one? Yeah, because the number in the basket and the fruit in the basket's going to change. It's going to be down 1. Right? Does that make sense? Okay, so I have a basket of apples. I take one out and eat it. Now, what's the probability I'm going to pick another apple? Well, I'm down 1 apple on the second one. So that's dependent too, right? Okay, he picks a kiwi and eats it. If he eats it, it changes it, right? So I'm moving on to D. Picks a kiwi, puts it back. Picks an apple, puts it back. Did he replace it each time?
Yes.
Yes, that makes it D, that they're independent. Good? Yeah? Lots of probability at the end of these. But let's say I have 50 in the first one, so he takes one out, but he puts it back. I still have 50 the second time, so it's without replacement because I didn't change the total in the basket each time. Good? All right. Probability of flipping a fair coin and heads landing face up is 0.5. Probability of rolling a fair number cube with sides numbered 1 through 6 and an odd number landing face up is 0.5. What's the probability of flipping heads or rolling an odd number? If it's an or, what do? Add or multiply? Add. Are they dependent on each other? Do you have your mutual exclusivity going on? Yeah, so we got to do the probability of the coin plus the probability of the odd number, and then take out the probability of the coin or number, right? Which actually is like multiplying. Are you with me on that formula? Remember that one? So if this one's 0.5 and I add 0.5, but I'm going to take out 0.5 times 0.5. Everybody with me? Yes? Thomas, where did I lose you? Are you seeing where I got these two? When I have mutually exclusive, I have to subtract out the multiplication of them. So 0.5 times 0.5 gives me 0.25. So 1 minus 0.25 is going to give me 0.75. I have to add for the two, but then since they're mutually exclusive, I have to subtract out the multiplication of the two for overlapping. Because that's what the formula says. Yeah, which gave me the 0.25. But 0.5 times 0.5, what's 5 times 5? It's mutually exclusive, not overlapping, I'm sorry. Because they're 0.5 times 0.5, 5 times 5 is 25. Right? And now I have 2 decimal spots. Whenever you multiply fractions, that's like saying 1/2 times 1/2. That gives me 1/4. Anytime you multiply 2 fractions together, you get smaller.
If you multiply something by 1 itself, go below 1, less than 1.
Okay. All right. 28. We have a translation. Create equations for A in terms of X and B to describe the translation. What did they do?
They moved it down.
Okay, let's talk about A is my X. So what did my X do? I went 1, 2, 3, 4. So that way, and did I go negative or positively? Whoops. No, I went negative. So X minus 4. And then what did I do with on the y? I went up to 3, so that would be y plus 3. Good?